Seuraavaksi päästetään ääneen seminaarin pääpuhuja, Dr. Sarah Cornell, ja Sarahista muutama sana. Hän on tutkija ja tiedekoordinaattori, joka käsittelee ihmisten ja ympäristön vuorovaikutuksen liittyviä kysymyksiä globaalin ilmastonmuutoksen yhteydessä. Sarah on ympäristökemian tohtori ja hänen tutkimuskohteitaan yhdistää monitieteisyys, joka vaatii sitoutumista sekä eri tieteenalojen välille että niiden ulkopuolelle. Hän tutkii muun muassa globaaleja ja biokemiallisia syklejä, sosiaalisia ympäristöjärjestelmiä sekä kestävää kehitystä. Tänään hänen aiheensa ja puheenvuoronsa kulkee otsikolla Climate Action as if the whole Earth matters. Welcome, Dr. Sarah Cornell. The stage is yours.
Thank you for switching to English. I'm really grateful for this opportunity. It's such a timely time to be talking about climate in its bigger context. As I presume you've heard, I'm an environmental scientist at Stockholm University, and my research really takes a global view of sustainability issues. Can I have the next slide, please? I'll say click. Okay. Can you click to that? Yes, thank you. In our research, we see the whole of planet Earth as a system. Sorry, I'm going to have to just move a little bit because it's beautifully sunny here and I don't want to complain about it. We see planet Earth as a system, not just as the physics of climate, but also really focusing on the interactions of social and ecological structures and processes. And it's in that context and with that perspective that today I'm just going to pick on three broad questions. One is quite simply, how much have human activities changed the world? Then, why isn't it enough to focus just on climate? And then after that, what actually is action, as if the whole world matters? Next slide, please. Yeah. So let's get started. How much have human activities changed the world? We can move to the next one straight away. One thing I really want to emphasize is that we should be thinking of Earth as a living Earth. Climate is really important, but it's looking at the physics of the planet. And we have very long-term climate records of just how much climate has changed all the way through Earth history. I love this picture, even confusing, so I'll just give you a little bit of an information about it first. The graph telescopes in time as you move from the left to the right. The first window in the graph is about millions of years to millions, and then in the final window on the right-hand side, it's about thousands of years. So you can imagine time squashing as you look into the deep past of Earth. And Earth has changed radically in that time. We often, as scientists, describe ourselves, as geologists, they would say the most period of Earth history is this Holocene. And relatively speaking, bearing in mind that it's pulled out rather than squashed up, relatively speaking, it is a period of extraordinary climatic and ecological stability. And human societies really have relied on that stability because it allows for predictability. And we'll come back to that point in a little while too. If you know that your crops will grow next year, you can start to build a settlement. If you know that the ocean currents are going to be reliable year by year, you can start to explore land. And so in a sense, this climatic and ecological stability that underpins a lot of what we now know as human civilization. So if we go to the next slide, we're in the process of changing all of that. We can explain a lot of this variability as scientists going through different disciplines contribute to different knowledge to this process. So when we look at long-term history, then we need to focus on things like the orbital changes, low volcanic activity and tectonics of the planet, and that gives us a picture. The ocean circulation and atmosphere circulation and the changes of the ice sheets give us a sort of an intermediate picture. And obviously, we really care about the short-term responses of life and its physical environment. And the field, in fact, my own field on this, is the understanding of the biogeochemistry of planet Earth. So with this science, we can actually explain a lot of these little wiggles that you see, like the shifts from glacial cycles to warm interglacial periods, and actually also the variability of Holocene. And it's because we can understand those processes that we can start to predict what will happen next on planet Earth. So if you click to the next slide, the fact that we can understand the physics, chemistry, and biology of a whole Earth system over millions of years means that we know that human activities now are changing the direction, they're changing the trajectory of climate on Earth. This is a picture with lots of little bits, but I'm just going to say we know the sources of carbon emissions. The little round graph on the top is a recent assessment of Europe's sources of greenhouse gas emissions. And it's not really surprising. We burn fossil fuels for transport and for heating, for industry, and that's the biggest contribution. But land use, food production, for instance, and waste are also significant additions to the greenhouse gas loading of the atmosphere. The more you put greenhouse gases into the atmosphere, the warmer the world gets, and that's what the upper graph shows. It shows how things have relative to the kind of the average temperature in the middle of last century. And it's that shift from a relatively stable condition to one where there's an upward trajectory in greenhouse gas emissions, the concentration of greenhouse gases in the atmosphere, and the detectable warming that is pushing us into a set of conditions that is much, much more uncertain and that is challenging the limits of prediction of our current models. So it's in that context that the world's nations agreed on the Paris Agreement. And if you look on the graph, we've got these two little dots that basically say, really, unless major efforts are taken now, we are already committed to sort of the 1.5, 2 degrees of warming that is the objective, the goal of the Paris Agreement, really within this century. And if we fail to act, we could end up with a much warmer world. Some scenarios indicate even up to 3, 4 degrees of warming in the lifetimes of many people who are living today. Next slide, please. But as I said, this is a living planet, and it isn't just about the physics of the atmosphere. We're in the ways that human activities are changing the living planet itself. Many of you might have noticed the publication of the Living Planet report last year. I mean, they publish it every couple of years, and every couple of years we show this sort of progressive decline in the abundance of species on Earth. Here, I mean, really, the most Living Planet reports have tended to focus on the things I always say with backbones and eyeballs, and the trends are bad enough for that. But increasingly, we're aware of the same kinds of effects on very small life, microorganisms, insects, and of course, the more you pull away, the more species that are put at threat or that are lost forever, the more that we unravel this web of life that we are part of. That isn't just at the species level, though. The weird graph, the green and orangey graph, is from a study that I really like, although it's quite complicated to explain in some ways. We're changing large-scale ecosystems too. And obviously in a way that it's at the larger scale that life and the biosphere, life and climate show that they're interacting. And we can start to see those effects, that the chipping away at the web of life, species by species, is starting to have this reduction in the richness of living nature and actually, quite simply, in the amount, the abundance of life on Earth. And we're increasingly concerned that that shrinkage below safe limits is going to bite back to us as human beings. Like I say, we are part of the web of life. Okay, the next slide, please. In a way, this is just a way to summarize what I said. The integrity of the living planet, are the thing that scientists call the biosphere, interacts with climate interacts with all of these other processes, the ways people use land and water resources, the way that we change the chemistry of the atmosphere and the ocean, the way that we change the kind of mental chemistry of life through things like the nitrogen and phosphorus cycles, the cycles of the elements that are the nutrients that support all life. And again, we're really very concerned about the fact, obviously we care about extinction because of the species, but the more that we realize how the effect of life, the more we realize that climate and the biosphere are the system that we need to be paying attention to. Let's move on one more slide. It's in the context of those interacting complex changes that the boundaries framework were designed. I work with Johan Rockström, who was previously the director of the Stockholm Resilience Centre, and other colleagues internationally who developed this framework as a way to show how much and in how many ways human activities are pushing planet Earth away from these long-term, stable, relatively predictable conditions. Each of the boundaries, each of these in this visualization of the framework is well documented. We have a lot of science monitoring both processes and the human disturbance of those processes. So this isn't a speculative, oh, maybe the world is going to change thing. This is sort of a backward look in some ways at how much the world has changed. And you can access really the sort of up-to-date assessments for each of these processes in a whole range of different assessment documents, like the IPCC for climate, the IPBES for biodiversity and ecosystem services, the forests and state of the oceans reports that the Food and Agriculture Organization produces, and many other ways of documenting the state of the world at the moment. The thing that all these reports say, and they're saying increasingly, and they're saying more loudly, more starkly, is that impacts are high already and risks are rising for all of the world's societies. So let's move on to the next bit. One more slide. When we take this backward look and when we take a systemic look, it's really, we must act on climate. But climate alone, as I think I've showed, is not enough. So let's move on one more. You'll see that I quite like pictures of strange pictures sometimes of the way that we can describe our impact on planet Earth. The square are the global warming stripes. A former colleague in the UK played with this visualization, and it's become really quite iconic at the moment. Each stripe is a year. You can find your own stripes for Helsinki, for instance, by looking on the website that I'll share the website later, the top corner of this presentation. But what it really shows is that it's just in recent decades that the warming has sort of really intensified. And by, wherever you look in the world, you see a very similar pattern to this. But we also have a very similar pressure on living. And again, the picture on the right-hand side, some kinds of ecosystems have improved, obviously, agriculture, people need to grow things in places that perhaps were not biologically productive in the past, but the vast majority of ecosystems and kind of habitats around the world have been degraded or destroyed even by human-caused land use changes. And again, this trend is worsening fast in our lives. So if we take one more slide. Yeah. We can present the planetary boundaries framework almost as a dashboard where, we can sort of say, okay, what's the state of play on each of these boundary processes, climate change, the loss of diversity. And we're in the rather disturbing situation that we're not just outside of the Holocene conditions, but as a global society, we're moving in the wrong direction fast. And in many cases, we're moving in the wrong direction fast, even though for 20 years or so, or more, coming up to 30 years, good Lord, we have excellent policies at the global level. What we really have is a serious implementation gap. And that's what brings us from this global perspective to the local levels of decision-making and action. So if we click one more, I'm definitely not denying that climate change is an urgent issue. But I think when people talk about the urgency of climate, very often they seem to be waiting for some kind of great big sign that we need to start acting. And this is where I've started to really find the idea that climate change is not a proper crisis quite an interesting way to sort of shape some of our research and some of our conversations. In the olden days, medics used to describe illness in two kinds of categories. The crisis, where, you'd encounter, an ill person would encounter some kind of acute change, and bless them, they'd either die or recover. So there was a kind of acute moment in a person's health that was kind of created by a set of specific circumstances. The other measure of health is this lysis, like in analysis, or lysis, if you're going to be Swedish about it. And there, the issue isn't about something that's kind of a set of circumstances makes something happen. It really is the sort of steady crumbling apart of a person's health and well-being. And if we start to apply this idea to planet Earth and the fact that we're pulling away at the web of life and we're steadily increasing emissions into an atmosphere that is tightly coupled to ecosystems and to our social systems as well, it's a rather, on one level, rather thing to take. It also helps us to understand a little bit why, even though things are urgent, it's proving to be so difficult to respond. I think it might be useful for us to think a little bit about this sort of this crumbling away from the global scale, again, down to the everyday levels of decision making. So if we click one more, I think when people talk about climate change being urgent, I also want to really emphasize that it's happening now. I mean, I think climate scientists have a tendency to talk about budgets that can be allocated and pathways that will take us to 2050 or 2100 or even beyond. But climate impacts are at crisis point already for many, many people in the world and for many ecosystems and other beings in the world. So if we take a social ecological perspective, we can also recognize that even though a crisis might be in one place, their effects are going to cascade ecologically and socio-economically far beyond their location. This picture is, I took it just from the UN refugee website just a couple of days ago. Every time I look, there is a new crisis, and it's got immensely detailed data. Very often these crisis response things count the number of 5-year-olds, they count the number of breastfeeding mothers, they count the number of tents destroyed or damaged. I mean, we have a huge amount of data, but again, there's sort of chronic inaction. Every time I look, there's a new crisis, and every time I look, the crisis is affecting thousands, if not millions of people. So here we are when we say climate is something that we need to tackle maybe by 2030. That is, I would say, a very serious part of the problem that we need to have more discussion about. If we click to the next slide, there have been so many efforts to bring the human being more centrally into our understanding of global climate change. One of my favorites, obviously there's a lot of academic discussion about this, but one of my favorites is Kate Raworth's very simple looking donut. She uses the planetary boundaries processes as the kind of the outer part of her framework, saying there's an environmental ceiling that we need to keep activities within, but we cannot forget the social foundations, the real foundations for decent living and well-being that country already agreed to. They've signed up to them in the Agenda 2030, in things like the Declaration on Human Rights, and many other global agreements about what this social foundation should be. The donut is lovely because it kind of reminds us of the purpose of the economy. That, you know, it isn't that it says this space is where our efforts should be focused. The safe, environmentally safe, and the socially just space. So if you click to the next slide, I'm going to start wrapping up now. Because obviously this is what you're going to be discussing for the rest of the day. Action as if the whole Earth matters. And I really want to just echo again the Agenda 2030 categories. Planet matters, obviously. People matter. But it's how we do it, not just what we do, that matters. And this is why the emphasis, I would say, needs to also be put on pathways for peace and partnership and prosperity that goes beyond just money calculations, but starts to recognize this deeper, richer, more multidimensional aspects of well-being. If we click on the next slide. For many years, I've read this comment that Martin Heyer, a professor at Utrecht University and the former social scientist in charge of the Netherlands Environmental Assessment Agency, made when the Planetary Boundaries Framework was published. He said, it's a great framework, but the problem is the idea that the planet has a cockpit, and in that cockpit, we can change course. The planet doesn't work like that. Well, in a way, it doesn't. There's no single person holding on to the steering wheel. It's not a wheel, the controls of the cockpit. But another way of looking at it is everybody is. And so there we have this sort of complicated challenge. What do we do when action involves everybody? And again, we have to see frameworks that recognize this challenge, and we talk about everybody must do it, but differentiated responsibilities. Kind of everybody must act according to their abilities, perhaps, or their responsibilities. So if you click to the next slide, we know what needs to be done. Like I said, many of these things, we've had policies in place for decades and a scientific understanding that extends way beyond that. For climate, cut emissions. For biodiversity, stop killing life. The ways we do that are through the ways that we manage land use and water use, that we handle waste and nutrient flows. So, like I say, we've got assessments, we've got science, we've got tools that businesses can use. But here, the real challenge is that if we think about this in terms of a system where people and nature are tightly, then we need to take not just any old action or even take these actions one by one. We need to take them informed by the fact that they interact with each other. If we act on climate change, we should be doing it in a way that supports biodiversity rather than contributes to the undermining and this unraveling of the web of life. If we click on the next slide. We also know how to do this. And I think, like I said, it's not just what you do, it's the way that you do it that matters when it comes to responding to climate change. We have global policies, and including the 2030 agenda, that really call for us to engage with the scientific knowledge as the base for action, but also the creativity and the concrete commitment of other actors in society. That's the political world, the private sector, and of course, citizens all over the place. One of my colleagues, Tina Herha, has presented this kind of framework, because obviously as a scientist, I tend to talk about the biophysical bit, throw it into a conversation and say, here you go, decision takers, act on this. We think that it's useful to break into steps. Science can say an awful lot about the scientific stuff. And in a way that helps us to really understand the fact that action here will have consequences over there or later or in some other part of an ecosystem. Our socioeconomic networks shift that predictive understanding. And so we need to have better ways of understanding and tracking responsibility, especially when it comes to resources and waste. And above all of this, we have the fact that any time science gives a budget or sets a target or calls for action on a particular trajectory for climate reductions. Every step has an ethical dimension. And so Tina argues very strongly that we really need to be thinking about the distribution and the action principles underneath the choices that we make. And that stops being science. That starts to be something about the dialogues of society. And I think that's really where I want to leave the conversation, because, or rather, leave the conversation to you, because this is very much about bringing together multiple perspectives. There is no single right ethical distribution calculus for climate action. Action as if the whole world matters tries to bring these three perspectives together. There, I'm going to stop so we have time for discussion. Thank you very much.
Thank you, Sarah. There was a lot of facts and figures. One thing that I'm thinking about is that we are living pretty weird times because of this pandemic. Is there anything that we can learn from these weird times that helps us in this fight against climate change?
I think very much so. Sorry, I'm going to just rotate a tiny bit more. Oh, welcome to my snow. One thing I think that the pandemic has forced us all to do is, in many cases, not for everybody, to do less and to accept that it takes more time. And in a way, at the moment, we're doing it without decisions. I mean, we're doing it reactively and and often with a lot for many households. Showing us something about the kinds of choices and the kinds of social conversations that we need to have if this is to be deliberate, and more importantly, if it's going to be more. Last year we thought it would be 2 months, maybe a year. We thought, the Spanish flu took 3 or 4 years and then it was okay. So we're in modern times, it'll be faster. And here we are entering another year of pandemic response, partly because not everybody's doing things the way they should, but still. I think it helping us to realize just what kinds of transformations are needed if we're going to cut emissions this year and next year and every year after that until 2050, which essentially is what is required for climate stabilization at any temperature.
In your presentation, you were listing different measures. But what would you say, what is the most urgent measure that you would like to see take action?
Oh, can I have 2? Obviously, cutting carbon emissions is absolutely vital, because carbon is the thing that connects the physics of the chemistry, of the climate system, living organisms, carbon-based life forms, and the flows that connect the biosphere with the physical environment. So cut carbon emissions, because that's the only way to stabilize climate at all. But like I say, it isn't just what you do, it's the way that you do it. And so the twin, I try to sort of say that climate and biodiversity are twin processes. If you cut carbon emissions, you should also be restoring and regenerating life. So there's, rather than simplifying, eroding and making monocrop plantations across the whole planet.
So in general, what would you say? Do you see any light at the end of the tunnel right now?
Oh, some days yes and some days no. One of the things that I really love about working at a university is that every year we get a fresh cohort, action-oriented, smart students. So that kind of is one of my major sources of inspiration. The possibility for refreshed year on year. I think the other thing that gives me optimism is actually having conversations a bit like this with the actual decision makers. Help me to sort of translate this sort of global picture of my everyday research to real on the ground decisions and action that are part of making the big sweeping goals into something that's livable and something that deals with these just plain happiness aspects of life.
Sounds good. Thank you so much, Sarah Cornell, and have a good day back in Sweden.
Thank you very much. Enjoy your discussions.
We will, thank you. Ja me jatkamme täältä suomeksi studiosta käsin.